Video I am going to explain regression analysis using the iris dataset. In this experiment, we will be implementing linear regression, multilinear regression, and logistic regression step by step. First, let's start with linear regression. First, I am importing the required libraries like pandas, numpy, and matplot library. Then I am reading the dataset using the pandas and displaying the first few rows. And next, I am checking for missing values using the isNull function. If there are any missing values, I am replacing them with the mean of the column. This step is very important because missing values can affect the model accuracy. And coming to the next, now I am selecting the independent variable as sample length centimeters and dependent variable as sample width centimeters. Here sample length is used to predict sample width. And coming to the next, I'm calculating the regression coefficients B0 and B1 using the formulas. B1 represents the slope and B0 represents the intercept. So the final equation becomes y equals to B0 plus B1 into x. And coming to the next, prediction. Using this equation, I'm calculating the predicted values of y. This shows how the model estimates the output. And coming to the next, now I'm calculating SSE, which is the sum of squared errors. It measures the difference between actual and the predicted values. And coming to the next, I'm calculating RMSE, which gives the average prediction error. Lower RMSE means better model performance. And coming to the next R square, then I calculate the R square values. It tells how the model fits the data. If it is closer to 1, the model is good. And coming to the next, finally, I'm plotting the graph using the scatter plot for actual values and the line for predicted values. This helps us visually understand the regression model. And now I'm predicting a new value by giving an input. This shows how the model works on unseen data. Now let's move to the multilinear regression. In multilinear regression, instead of one input, we used multiple inputs to predict the output. And here I'm using sample length centimeter and petal length a centimeter as input and sample width centimeters as output. And now I'm adding a column of ones to represent the intercept term here. Now I'm using the normal equation to calculate coefficient. This directly gives me B0, B1 and B2. So the equation becomes y equals to B0 plus B1 into x1 plus B2 into x2. And coming to the next, prediction. And I am calculating the predicted values using this equation. And then I'm calculating SSE, RMSE, and R square to evaluate the model. And finally, I predict the output of new input values. Now let's move to the logistic regression. First, I handle the missing values and convert categorical data into numerical using a label encoding. This is required because machine learning model works only with the numbers. And coming to the next features, I am selecting multiple features like sample width, sample length, and petal width and petal length. And And logistic regression uses a sigmoid function. This converts values between 0 and 1. And then I define a cost function to measure the error. And gradient descent to reduce the error step by step. It updates the parameters to improve accuracy. And I plot the cost iterations to see how the model is learning. And coming to the next prediction, I predict the values using threshold of zero point 0.5. And coming to the accuracy, finally, I calculate the accuracy of the model. This tells how many predictions are correct. And to conclude, in this experiment, we implement linear regression, multilinear regression, and logistic regression and evaluate their performance using different matrices. Thank you.